Proxima Centauri, the closest star to our planetary gathering, has for quite a while been a subject of interest for cosmologists. This little red midget, found in 1915 by Scottish space master Robert Innes, is fundamental for the Alpha Centauri system, which likewise incorporates Alpha Centauri and B no matter what its vicinity, simply 4.24 light years away, stays undetectable to the unaided eye due, in any case, to its moderately low brightness. Proxima Centauri holds huge logical worth, especially as the half-star of Proxima B, an exoplanet that circles inside the star's livable zone. Red diminutive people like Proxima Centauri are more modest, cooler, and fundamentally longer, live in stars like our sun. Their low radiance makes them trying to notice, yet it likewise implies their livable zones are a lot nearer to the star. For Proxima Centauri, this implies an orbital distance of just 0.05 cosmic units, a small part of the distance among Earth and the Sun. This closeness opens Proxima B to extreme heavenly action, including regular sun-based flares and elevated degrees of radiation, making its air particularly unique in relation to Earth's. The revelation of Proxima B was an astounding achievement in exoplanet research. Utilizing the spiral speed technique, space experts distinguished unobtrusive wobbles in Proxima and its position brought about by the gravitational draw of a circling planet. These wobbles permitted specialists to measure the planet's mass and orbital period. In 2016, the European Southern Observatory formally affirmed the presence of Proxima B, denoting a forward leap in the quest for possibly decent universes past our nearby planet group. While ground-based perceptions have given critical experiences into Proxima B, they accompany tremendous imperatives, environmental twisting. Furthermore, light impedance forestall Earth-based telescopes from catching point-by-point data about the planet's surface or environment. The vast majority of the information we have, for example, its mass separation from the star and orbital attributes, relies upon circuitous estimations to uncover further bits of knowledge into Proxima's climate and its true capacity forever. Further developed observational instruments like the James Webb Space Telescope JWST basic Proxima's and his job as a door to understanding exoplanetary frameworks couldn't possibly be more significant. As the closest star framework to Earth, it offers a remarkable chance to study the conditions fundamental for life. Proxima B specifically addresses a tempting chance, a rough Earth-sized planet with the possibility to hold onto water and maybe life. Anyway, the difficulties presented by its brutal environment make it a complex riddle for specialists to settle. The James Webb Space Telescope isn't simply one more apparatus in the armory of stargazing. It is a transformation intended to succeed. The Hubble Space Telescope JWST was imagined to address the constraints of its ancestor and push the limits of human information. While Hubble has given critical bits of knowledge into the universe, its capacities are restricted by its attention on apparent and bright light. JWST, on the other hand, is work to notice the universe in infrared frequencies, permitting it to look through tremendous residue mist and uncover peculiarities imperceptible to Hubble. One of the key plan elements of JWST is its essential mirror, which ranges an amazing 6.5 m in diameter, over 2 times the size of Hubble's mirror. This bigger mirror empowers JWST to accumulate considerably more light, making it fit of noticing extraordinarily weak and far-off objects covered with a slight layer of gold. To upgrade its infrared reflectivity, the mirror is made out of 18 hexagonal sections that cooperate to shape a profoundly delicate observational stage. Another weighty improvement is JWST layered sun safeguard, which keeps the telescope's instrument at a steady temperature of about 233 degrees. This ultra-cold climate is vital for identifying faint infrared signals without obstruction from the telescope's own intensity, not at all like Hubble, which circles Earth. JWST works from the second range point L to a steady position, around 1.5 million kilometers from our planet. This area limits impedance from Earth's intensity and light permitting JWST to keep up with persistent perceptions. The telescope can concentrate on everything from the earliest universes to the heirs of exoplanets like Proxima B. Its capacity to distinguish infrared light is particularly significant as it permits space experts to center around redshifted peculiarities objects whose light has been extended to longer frequencies as the universe grows. JWST capacities reach out a long ways past straightforward perception. It is intended to reply probably the most principal questions in science, including the beginning of worlds, the development of stars, and the conditions that could uphold life on different planets. With its cutting-edge instruments, including the close-to-infrared camera NCAM, the mid-infrared instrument MIRI, and the close-to-infrared spectrograph IMPEC, JWST isn't simply a telescope. It is a time machine, a lab, and a demonstration of human creativity. Proxima B has spellbound researchers and people in general, the same as an expected optional Earth arranged inside its star's tenable zone. The planet has the right circumstances to possibly support fluid water, a key component for life as far as we might be concerned, with a mass generally 1.17 times that of Earth. Proxima B is reasonable, a rough planet, comparative in creation to our own. Its closeness to Earth, a little more than 4 light years away, makes it an optimal objective for reading up the potential for life past our planetary group. Anyway, Proxima B is a long way from an optimal TTN of Earth. One of its most striking highlights is that it is tidally locked, meaning one side of the planet is in ceaseless daylight while the other is in timeless haziness. This establishes an extraordinary climate with outrageous temperature contrast between the two halves of the globe. The district where day meets night, known as the eliminator line, may offer a thin particular zone with conditions sufficiently gentle to help life. The difficulties presented by Proxima honeybees environment are huge. Its star, Proxima Centauri, is a red midget known for its extraordinary sun-powered flares, which can produce eruptions of X-beams and bright radiation. These flares could strip away the planet's environment over the long haul, presenting its surface to the cruelty of space. Assuming that Proxima B holds any air, it would probably require a solid attractive field to safeguard it from radiation. Without such security, the surface and climate would be antagonistic to life as far as we might be concerned. Regardless of these challenges, researchers stay confident about the potential for life on Proxima B. The planet's area inside the tenable zone proposes that fluid water would be able to exist either on its surface or in subsurface. Applies life might adjust to the brutal circumstances similar as extremophiles on Earth. Life forms that flourish in outrageous conditions, for example, remote ocean aqueous vents or high radiation zones. These transformations could incorporate radiation opposition subsurface territories or one-of-a-kind biochemical cycles. The quest for life on Proxima B is more than simply a logical undertaking. It is a mission to respond to quite possibly of humankind's most established questions. Are we alone in the universe? Proxima B presents a captivating probability, a rough Earth-like world that could hold on to the circumstances important for life. As our innovation propels, so too does our capacity to investigate this interesting planet and uncover its mysteries. While Proxima B presents enticing conceivable outcomes, Its current circumstance is significantly impacted by the idea of its host star Proxima, sent in not at all like our sun Proxima Centauri is. A red midget more modest, cooler, and fundamentally less radiant. Its decreased size and temperature imply that its livable zone is a lot nearer pulling Proxima B into a circle simply 0.05 galactic units from the star, about multiple times nearer than Earth is to the Sun. This vicinity makes an extraordinary set of difficulties for the planet and any potential life it might hold on to. One critical issue is Proxima Centauri heavenly movement, especially its extreme and incessant sun-oriented flares. These flares are abrupt, strong eruptions of energy that discharge high portions of X-beams. What's more, bright radiation, such occasions are considerably more typical and lively in red, smaller people than in stars like our Sun. For Proxima B, this implies a consistent torrent of high-energy particles which could strip away the planet's air over time without a defensive attractive field. Any climate on Proxima B would be powerless against disintegration, uncovering its surface to unforgiving radiation, regardless of weather. Proxima B holds a portion of its climate. The radiation from Proxima Centauri presents serious difficulties forever. Elevated degrees of bright radiation can break subatomic bonds, forestalling the arrangement of complicated natural mixtures. This would seriously restrict the potential for life to create or support itself on the planet. Its surface on Earth, living beings like Deinococcus radiodurans have developed instruments to fix DNA harm brought about by radiation, proposing that life on Proxima B could correspondingly adjust. Anyway, the level of radiation obstruction required would be outrageous, possibly requiring altogether new biochemistries. Curiously, Proxima B's clean-locked nature might offer some security while one portion of the planet faces consistent radiation from Proxima Centauri. The planet-clouded side could go about as a shelter. Subsurface areas or profound caverns could safeguard potential life structures from the most awful of the radiation. Moreover, if Proxima B has subsurface seas, they could give a steady, without radiation, climate where microbial life may flourish, similar as the environments around aqueous vents on Earth. Regardless of these difficulties, researchers remain hopeful that Proxima B's exceptional climate offers a significant chance to concentrate on the flexibility of life by figuring out how living beings could make do or even flourish under such conditions.